One major thing we have to deal with in our chemistry course this semester is how to deal with how well we know a number. To be able to express this, we use something called significant figures. The idea behind all of these is just, how well do I know a number? Because there's a big difference between taking some water and pouring into a beaker and eyeballing it versus being really careful with a micropipette to get exactly how much I want. And even when I'm being more exact, I never know the number all the way as far right as possible. There's always some limitation. There's some amount of error that's going to be present in my measurement. So how much is that, and how do I then show that to other people? So here's what we do. First, this is just going to be counting significant figures with single numbers. And this isn't about when you're measuring it yourself, like when you've got to figure out how accurate your particular device is. But this is when looking information from someone else, such as in a problem in the textbook or on an exam. So here, we're going to start. There we go. So we're going to start here with 123. This number is the most straightforward. And this follows just the very first rule we have for significant figures. First rule, all non-zero numbers are significant. And I will finish the rest of it. So in this case, our answer is quite simple. All our numbers are non-zero, so this has three significant figures because the 1, the 2, and the 3 all count. That covers that case, and that case will be the most straightforward, so we don't have to worry about it. We don't need any more rules. If there are no zeros, we don't have to worry about it. But the next question is, what do we do if there are zeros? How do I know why some zeros are going to count and why some aren't for how well I know a number? Well, what's going to matter is there a decimal place or not in our number? Because we're going to have two different variations of our rule. So we'll start with the simpler case, when there is no decimal place. If there is no decimal place, then what matters is we only count zeros that are between two significant non-zero numbers that are significant. So any zeros that aren't between two non-zero significant figures don't count if there's no decimal place. So for example, in 1200, these two zeros are not between any significant figures, so they don't count. We only count this one and this one. So this number has two significant figures, and I'm just going to abbreviate that SF. Then we have the next one. We have a number like 2030. In this case, this zero isn't going to count because it's not between two non-zero numbers. This 3 and this 2 count because they're non-zero. And this 0 counts here because it is between two non-zero numbers. So this number has three significant figures. We can also take the case, I don't have an example written there, of a number like 120 dot. This number, in this case, has a decimal place. So you'll notice we can't use our rule. So our rule doesn't tell us to get this 0. So we're going to need a different rule to deal with when there's a decimal place in our setup. So what if there is a decimal place? So we'll take an example like this first one here, 0.0. So we have 0.0040. What we need to do is locate the first non-zero number. Every 0 to the right of the first non-zero number is significant. So our first non-zero number here is 4. Every 0 to the right of 4 is significant. So this 0 is significant. This gives us two significant figures. All the zeros to the left here are not significant because they are to the left of the 4. So find your first non-zero number. All zeros to the right of it are significant if there is a decimal place in our problem. So that's this thing right here. Let's take another example. 1.040. Our first non-zero number is this number 1 here. That means every 0 to the right is significant. So this 0 is significant and this 0. And we also know this 4 is significant because it's a non-zero number. That means this has 4 significant figures. Then finally, we have this third example of 0.03403. Our first non-zero number is this 3 here. That means this 0 and this 0 are not significant. But this one right here is. We also know the 4 and 3 are significant because they're non-zero numbers. That means 0.03403 has 4 significant figures. I note that this is a slightly different way than I worded it in class, and hopefully this way makes a little more sense. We're looking at whether we have a decimal place or not. If there is no decimal place, we only count zeros that are between two significant figures. That means two non-zero numbers. If there is a decimal place, that means we're going to look for the first non-zero significant figure. Every number to the right of that non-zero significant figure is significant. Every zero to the left of that is not. So hopefully that will be a shorter set of rules that will help with being able to count significant figures and how to figure out whether your zeros count or not. And then finally, just as a reminder, let's say we have something like 120 point. If you remember this rule when you were talking at workshop sometimes. Here there is a decimal place. So our first non-zero number that is a significant figure is this 1. That means this 0 counts. It is significant. That is 3 sig figs. But if I had written the number 120 without a decimal place, then we would only count zeros that occur between two non-zero numbers. And here, this 0 isn't between two non-zero numbers. So this number only has 2 significant figures. So that's how we can know whether the decimal place matters or not, how it will impact a number that otherwise looks the same all the time. 120 versus 120 with a decimal place. So far, this just covers what to do about counting significant figures in a single number. The next question we have is, what do we do when we have to do some arithmetic with these numbers? There are 2 categories that we deal with. The one we will deal with probably the most is with multiplication and division. In the case of multiplication and division, we use the number with the least number of significant figures. So in this example, the first one, we have 120 divided by 40. Our number 120 has 2 significant figures. Our number 40 only has 1 significant figure. That means our answer is 3, because it should only have 1 significant figure because that's how many 40 has. On the other hand, if we had had a 120 dot divided by 40 decimal, then we would have had to write 3.0 because 40 has 2 significant figures when it has this decimal here. And therefore our final answer would also need to have 2 significant figures. So that gets our first example through. Let's try our next one. So here we have 123, and we multiply it times 5.4 times 10 to the third. Here, we're going to have 2 significant figures here, 3 in this number, so we're only going to have an answer with 2 significant figures. When I put it in my calculator, this would give me 6.6 times 10 to the 10 to the 5th power. And that's the way we can write a number with 2 significant figures. One note I want to make is how I put this in my calculator, just to make sure you're okay with that. So 123 we're probably all comfortable with. We know how to put that in a calculator. You then have a multiplication sign. If your calculator has this function, what I do is I put 5.4 in, and then I press a button that's a small capital E. There will usually be 2 of them that show up on the button, but it's just going to show up as 1 on your calculator, and then you put a 5 here. This makes it so it's easier, so you don't have to manage parentheses as much when doing your answer. This will keep the 5.4 with its understood times 10 to the... Sorry, that should not be a 5. That should be a 3. I was looking at the wrong problem. Sorry about that. 5.4 E3. So what that does is that tells the calculator to put this in. 123 times 5.4, and that E stands for times 10 to the power of the number you put there. So that's just a shorthand way of doing it that can make it easier to put in your calculator. So as we can see, multiplication and division are about counting the number of significant figures and using the number with the least significant figures as your basis for how many significant figures to put in your answer. Many times your calculator will give you more numbers than that. If it does, for example, with this number up here, the 6.6 I have, the way I got that is that I rounded the rest of it, because my calculator told me that the answer was 664,200. But I had to round it to the second significant figure because that's all I know well within the context of my problem. We'll just do one example like this, although there's more in the text I suggest you practice if you have trouble, is what do I do with adding and subtracting? Both adding and subtracting follow the same rules, which are different than the ones we just did. So it's not like multiplication and division. In this case, what we have to do is we have to worry about where our decimal place is. We want to keep the fewest decimal places. So for example, here we have 100. When we put it in our calculator, we would get 142.99. However, we don't know the number that well. We don't actually know this place right here. We don't know the hundredths digit. So we would say that the answer was 143.0 is what we would say our answer was, because we only know to the tenths digit. I'll also note that this also counts even when our addition subtraction. That covers what we need. So here, we weren't counting significant figures. That's the main thing. When we did the subtraction or addition, we were counting decimal places. We do the counting of significant figures with multiplication and division. This is something I suggest. If what I said, if this seems kind of confusing, I strongly encourage you to do some practice with it, because this is one of the things, as you practice more, it can help you get comfortable with it. That way it's something you don't have to think about as much when you're doing problems that are more complex. I'm also happy if you want to come by my office and I'll work with you. We'll do some practice with it, because this is one of those things that just practice can help you get a lot better at it.